Okay, conceptual physics students and possibly some parents, here are some hints for the Chapter 35 textbook assignment. Just a few hints on some of the problems, and this will go quickly, so feel free to click the pause button and work out the problem and then continue. Look at number 20. Number 20 being a parallel circuit, to find the equivalent resistance, you use 1 over R eq, equivalent resistance equals 1 over R1 plus 1 over R2. So for this one, we have 1 over the equivalent resistance equals 1 over 6 plus 1 over 6. Let's get back there. And of course, you're going to use the common denominators that are already there. Remember, there is a last step. And you recall from class that the last step is to take the reciprocal, and that'll fix number 24. Let's look at number 23. So for number 23, first find the equivalent resistance for the series circuit. Different formula. That's the equivalent resistance is just the resistors added together. Okay. When you're finished with that and you get the equivalent resistance, it's time then to use Ohm's law. So use Ohm's law to finish this. Remember, Ohm's law is written 3 different ways depending on what you'd like to solve for. So it is either V equals I times R, or I is equal to voltage over resistance, or sometimes it is useful to view it as the resistance equals the voltage over the current. Let's jump down to number 49. Number 49, all I have to give you as a hint is to use Ohm's law, like we just talked about. Should help you a lot. Let's go now to a more complicated questions, number 52. Part A has an equivalent circuit. So again, you're going to use the 1 over the equivalent resistance equals 1 over R1 plus 1 over R2. That's for the parallel part. So that should help you with part A. For part B, you now have 3 resistors to combine using the series circuit rule. So for part B of number 52, you have 3 resistors to combine. You have a 20 ohm resistor that you see there in the circuit, okay? And you're going to combine that to an equivalent resistance. There's a REQ. This is for the parallel resistors because they're now one pretend resistor. And finally, you're going to add to that a 15 ohm resistor. That should help you on number 52. Great, let's look at number 54. Well, again, as you're getting used to, we are going to use the equivalent resistant rule for a parallel circuit. The 30 ohm resistors can be combined to make one equivalent resistor. When you're finished with that, then you have a simple circuit, and you can add all the series resistors together. Finishing the problem, to finish the problem, you could use Ohm's law. Okay, you're starting to see a pattern here, I think. One more hint. Let's look at number 56. Number 56, they tell you that that you have 4 watts. 4 watts is a measure of power. So when you use your formula sheet, you want a formula that has power in it. So for part A, write the knowns and unknowns as we're getting used to do. Make a little list of the knowns and unknowns. So I'll give you a hint. They have told you that the power is 4 watts. They also told you that this is connected to 120 volts like you get in almost everybody's house. But the current is what we wish to find. Write it as a question mark. Then you simply find the one formula that has power, voltage, and current. For part B, let's use Ohm's law. Part C, they ask about the cost. Well, first let's use energy equals power times time. Remember, hint, change power, change the power, which is at this moment in watts, to kilowatts. So change that first to kilowatts. And how about the time? 30 days should be changed to hours because you get charged for kilowatt hours at your house. I think that should do it.